All right, so I'm going to keep this short. So most of the time when people use Kubernetes, they think about these pieces and how the complexity plane goes together in reference to the overall project. Normally they think of using tools like this, and this can be great for if you're doing industrial or large-scale automation, but eventually it gets a bit complex. And what I wanted to figure out was the simplest way to deploy it to Kubernetes, because it's a very complex tool. And one of my things is that anything too complex will be considered not necessarily valuable, even for the developer or the company in question that needs to make use of this tool. So, a lot of what I would like to consider is how do we simplify it? And one of the things that I've found is that Acorn can technically remove some of that complexity. Now, why use it? It builds off of the existing thing that Kubernetes is using. That could be kind, that could be Minikube. Design it however you want, stand it however you want up, even if you're using K3S or K3D. But things like Rancher to me would seem a bit more complex than things like Acorn could handle. So I don't think it would be useful for it. So from my understanding of it and how it works is you have a bunch of internal API calls. They look like a bunch of REST calls. And they go in and talk to each other and run around and do all sorts of setup. But as you can see, it abstracts most of the complexity away. And that's nice, but how does it make it useful for security rules? Well, you have to implement those differently. From the documentation I've read, it is considered a set of roles and cluster roles, or permissions, as they put it. And the permissions itself seem fairly simple, because you can define it separate rules specifically for the cluster versus just that one container. And the separation of these types of rules makes it a bit easier to configure, because most of the internal complexity has been already automated out of the equation. And so this black box that is Kubernetes, most people don't have to think about anymore, because that black box has been redesigned as a simple set of information. So it's mostly config, but the configuration and how it does something useful with that config, for many people trying to learn it or get into the industry and make use of it, it can be very difficult, because they have to deal with this intermediate part of dealing with the internal state, internal structure, and manually managing all that. So instead, what I've noticed is that the Acorn developers just tacked on things that would be essential for both interacting with Docker and Kubernetes itself. And it's really nice. So thus far, I've figured out how to use it in a fairly simple manner just by reading the documentation, but I did also notice that I had to bang my head on the desk to figure it out. What do I mean? What I mean is most of Kubernetes is so complex that most people will not understand its basic utility functions, what it can be utilized for. And so they will look for an alternative that isn't necessarily Kubernetes and come up short. And then give up, because the overall curve it takes to learn, they won't be able to hit beyond the edge of the curve. So Acorn, in theory, is meant to sidestep that problem and go, hey, no. All the app building you used to do, you can still do that. but here's the sets of tools to use to make sure, like when you're using Kubernetes normally, as if you're using Docker-like interactions, which makes it a bit easier. So the pros and cons. The pros include it being overly simplified, easier to use, and you get to recycle some of the logic you used to use for Docker. The problems in the cons section are misconfiguration. So if you misconfigure it, it'll do the thing you asked it to because it thinks it has the proper config, at least enough to meet the objective you told it. But the problem is if you don't give it the necessary information to do that proper config, it'll do the configuration and functionally configure into a misconfigured state. And so that's also a problem, but once you've reached it with Acorn at this level, you know how to go back and debug. So that technically is half a pro and half a con. Mismapping of IP and endpoints. So if you have a mismatch, either you've given it the wrong IP, you've given it the wrong controller, whatever, you've given it something that it doesn't agree with down at the runtime level. Well, Acorn will understand how to configure it as if it's the right configuration. And the overall conflict becomes API conflict, leading to misconfiguration of your application. And I figured this out when I was trying to use things like ngrok with Acorn. Because for whatever reason, the HA proxy they use in ngrok versus the Acorn proxy that's built off of the kube proxy, and both of them are built separately and differently from the initial kube proxy. They technically, at the API level, do the same thing, but how they do it conflict. And so they have conflicting tables of rules. Acorn itself has a ossacorn.io or local.ossacorn.io by default. ngrok has a ngrok.io most times. And if you're using the free version, that can be beneficial, but the conflict is still there. The conflict is you can't use it necessarily the way you would think it would be used normally in ordinary Kubernetes standup. So instead, you'll have to use a subcontainer that spawns this as a separate process to do the same thing. Now, yes, it'll still log the output, but it's more work to get it to do that for free. So that can be a problem of misconfiguration. You configured it correctly, you set it up correctly, but the cookie cutter setup you thought it would work in just does not fit. So it's an illogical fit to the puzzle piece, even though it's the right one for the job. Improper implementation. So if you're looking to implement something like ngrok, like I tried, I believe I implemented the method of configuration improperly. I personally would find another tool than ngrok, or figure another alternative way to use it in a non-Kubernetes setup inside of a kube-like container. So that's another problem, is you're going to have to readjust for functionally misconfigured. And what I mean in that is it's functional, but it's going to run attempting to address and use that misconfiguration as if it's valid. And whether or not it meets the validation check, it can still be invalid. So careful testing of your code, careful testing of the stack operation you're trying to do, and careful testing of where you're trying to get the stack to do the right thing so that it can be used outside of the local cluster. That can be difficult to set up and configure from the ordinary configuration. There are many security rules you have to consider. There are many very specific names you have to consider about the configuration you're applying, all sorts of stuff that Acorn automates away. And so technically that part's a positive. But what it leaves as a negative is, due to the automation process of that being removed, it makes it a bit harder. So technically it's a add-on tool, and the add-on should be used with respect. And so that's one thing that you should consider when building things, even with Acorn. Is it built correctly? Does it respect the security rules? Does it follow the right configuration? And if it's Quasimodo level of right configuration, how do we step it out of Quasimodo into functional for deployment? Because you don't want your project stuck in production forever. Well, how many files does it take for a simple stand-up? Not very many. As you can see, it's as simple as a few scripts, some config, and this is the amount of files that I use, roughly 5, because I was looking to stand up a basic Flask-based website. So why should I use this? Well, this method makes it a bit easier, and if you're using ngrok separate from this, outside of it, you can definitely take the advantage of using an intermediate that reroutes from the acorn URL to an ngrok one. And that requires using a separate Flask server to do that routing. Now, I dislike that, but it is a workaround. The other workaround is to use ngrok as a sub-process that spawns in reference to your app and have it use the main entry point. And that can technically sidestep that problem. Now, yes, you'll still need to use root privileges, even if you're using this in rootless mode. The one thing I will say about setting it up in rootless mode is that even in rootless mode, you will need to use Minikube Tunnel if you're using it with Minikube. Now, the reason this demonstration demonstrates the Minikube setup is because I set it up that way initially. When I initially built the Acorn app I was trying to, I initially wanted to test it on Kind, because if I got it set up on Kind and Minikube, it could, from that point, be set up so that anyone can use it from a localhost machine. Now, the idea behind that was to save on both infrastructural cost and the ability to get it out to the public in time. So cutting down of overall time to live. And that, I think, comes down equally to simplicity or complexity. The more complex you made it, and the harder it is to use that complex thing in a simple manner, the less value it has. And so that was part of the thinking of over-engineering being the problem. And I didn't want to over-engineer a solution. So what else can be done with it? Well, from my standpoint, if you're really clever, you can create custom device configuration, meaning you can create virtual hardware. You can customize the functionality of those devices. You can add functionality that wasn't there before. You can put in stand-in functions. You can imitate all sorts of bits of hardware if you know what you're doing. Now, I've learned a bit of Python, C, Java, assembly, but the one thing I haven't learned is Golang. But that's neither here nor there. So literally, in some cases, this being one of them. And the real answer to the overall optimization problem, even for security, is this. It's a lot of complexity, but it does a lot of simple stuff. It's produced apps, tools, and usable infrastructure for most of what we're trying to do, not only in a secured manner, but in an unsecured manner. That could be anything from running Minecraft servers to infrastructure that does large data transformations. It can be SQL between two database setups that need to have this type of interaction. What have you. But I will point out that the inside of Kubernetes looks as complex as this. Now, this image itself is a breakdown of the disassembly and overall way that it runs under the hood when you hit Java run or Java-jar and then give it your code. And so this is some of the way it looks like when it's doing the runaround under the hood. Now imagine that being Kubernetes. When most people look at that diagram, they go, nope. And in their head, they're like, no, I won't be able to fix that. But when you look at Acorn, it doesn't look that complex because of the way it abstracts that away in a simplified manner. The more tools that developers and engineers have like this, the easier it is for even them to do the job. So technically, what does it say about our language use? Well, it says that it's simple, complex, and crazy amount of connect the dots. Sometimes it's a dinosaur, sometimes it's a lemur. Sometimes you get a nice little calculator out of it. So how much complexity is too much? Well, too much is it's putting excess load onto the system. Overutilization. It's creating bottlenecks because of the amount of requests it's got to make and address. Potential conflicts between API calls or API calls that don't conflict but have a lot of time between requests. And that's just REST APIs. So the longer an internal API takes to respond, even for Kubernetes, at the REST API level, the longer it'll take for anything in production or development to run. And so any amount of impedance, even the slightest, might make it harder for your thing to work. Over-constraining the system's resources and misconfiguring it can also make it harder, which can be an added dependency problem. So too many dependencies can also encumber your project. It may even kill a project. The other thing about conflicting APIs and API calls, implementation. If your implementation's too complex, almost no one will want to use it. No one will touch it. No one will bother to look at it. They'll just turn a blind eye. Well, the reason is too complicated to debug, too hard to maintain, and probably not enough documentation. And while initially certain implementations that have that can be beneficial, it's the cutting of the corner that creates added complexity. And so when you're cutting those corners too many times, you'll eventually have something that's too complex, and you won't be able to use the paper. So analyzing the needs to avoid that problem. What should it do? Does it need a database? Does it need knowledge of Kubernetes? Does it need Nginx knowledge of the world? And does it need storage? Do you need east and west to synchronize or not? And so one of the other things I had to consider before even making this presentation was, do I set it up with a normal minimum config of a database, like in the examples, or do I consider using something that is compatible with Google Spreadsheet and Python? Now, as a Python developer and Python software engineer, I tend to look for things that are simple enough to use, don't add too much complexity, and keep functionality. What I don't like is trying to go from overly complex to overly simple. But if it must be done, it must be done. And so one of those things in databases and this type of problem is not necessarily misconfiguration, but the timing. Do they have an ability to synchronize reads and writes? And any amount of desynchronization in time at any one point can cause a misread or a miswrite in timing. The reason I look towards things that interface with Google Spreadsheet and Python is to avoid that problem of if all the two need is an RPC channel between each other and a Google spreadsheet that they're both looking at, they can both do the same step of analysis of looking at the same sheet for the necessary information to write data to the right place synchronously, as well as which database in east or west in the network tree. And so that's also important to analyze. Now, this one I didn't finish fully, but over-engineered solutions look like, well, complex code pasta. If your code looks like spaghetti, not many people are going to know how it works, and when you talk to them about it, they may not fully understand the whole of it. So you're going to have to tell them from the beginning what you did, and that'll take time and be a bit of a hassle. But you're going to have to bring up the XY problem, because if it's complex spaghetti, they failed to analyze from the beginning where they were solving a Y problem, which created that spaghetti, because they solved for Y as if it was X, because in their head, Y equaled X, because to them it was a new X problem. So that's one thing that needs to be analyzed. Too many copied dependencies. The more dependencies you have, the more encumbrance it takes on. That includes if it requires disk. So that encumbrance adds to the problem of complex spaghetti. The more parts that move, the harder it is to figure out what style of movement it can do. In this case, Kubernetes can do a lot, but if it doesn't know the type of complex voodoo you're asking it, it's going to try. It'll do a hop, skip, and a dance. But what it won't do is the expected hop, skip, and dance unless you simplified it for it to do that the right way. And so that's one of the things that people run into in the industry is they have this conflict in complex thinking of you're both thinking about it on the same sets of terms, but how you're trying to solve it is different. Conflicting code paths leading to code complexity and code pasta. If you have too many interdependent things that use different API structures for whatever reason, and you're writing over each other's code, the problem is you're writing over each other's code, and you both didn't communicate to each other where this was happening, or before you would have gotten to that point. And so that's also a thing to address, because in the industry, you don't want to be the problem child that destroys a project or makes it take forever. So that can be a problem. The other thing that can equally be a problem is that in that process, if you've communicated and felt unheard, the other problem is that if you've communicated a thing and you're trying to address what you were asked to, and somebody else equally tries to address it, how do you communicate it up the chain? And that's something that many people need to consider, is like, how do you communicate it back up the chain that there is this problem prior to addressing the actual problem both of you are trying to solve? So it's walking it back all the way up the tree to that point and asking, hey, why are we both doing the same thing? Why didn't that part of the team over there get the same notice I should have gotten? And why wasn't I brought up on the same page or to the same speed? And so that's also a thing of like team management. How do you, at a juncture like that, prevent that conflict? because both of them will have interest in the same solution. But how do you get those two to work together to produce zero problem children? And so that's also complexity that you have to consider. Mainly if you're trying to reduce code pasta and create a simple stand-up. And so that should, in theory, be a thing we can address. Now, I didn't have time to finish this slide to add it, but you can see where I was going. And so most of what I was trying to do personally was create a website that ran for free without anyone paying for a registrar for a domain name. And so I got pretty close. But the answer was simple. I was making it more complex for me, accidentally, because I wasn't seeing where I was overthinking it. And so overthinking on both sides of the problem and the equation, and for management, can lead to that type of fractalization where two people are doing the same solution or solving for the same problem, but with different solution sets applied or problem solving skills to it, because it's the same type of critical thinking and risk assessment, but it's applied differently. And so if they were pair coders, one of them would be learning from the other chief that the style of addressment they were trying to do was solving a Y problem. And so that's something that they have to become comfortable with over time. So a misbalanced environment, even in the workplace, even in a thing that's Kubernetes related and for business purposes surrounding Kubernetes, like that's a thing that many people have to consider. I have to consider it before entering the field of how do I not butt the heads. I personally don't like butting heads, but if I have to, I know what sets of communication are needed. By the same token, I don't want to be the only one who knows how to surf that problem and navigate around that problem, because that's not necessarily a thing that I would consider fair. And so to me, people being able to access information like this that'll bring them up to speed on how to get in and how to address it makes it a bit easier. And I have to thank even the Acorn developers that I talked to, because most of what I had to consider was whether or not I was getting the thing I was trying right. And it turned out I was 98% of the way there. But I overlooked 2% error. And so that 2.01% error almost fucked over the entirety of the project that I was working on, and would have been a complete waste of my time. And so I'm glad to not have and talk to them, because they were more experienced in how to use that part of Kubernetes in a way that I just don't know how to use yet. I just don't have that experience yet for that type of security analysis and security set in the way that they do for OPSEC. I understand security very differently. And so what I do are things that allow me to take apart an app and rebuild it to prevent the security problem. And the same is true of building a website. I pick apart the components that are essential to building that website. For even my boss, who requires me to do basic web development at the moment. But on the whole, I was looking for the simplest thing that abstracted the complexity away. And even my boss was looking for that type of solution. And so it's knowing exactly what they're looking for. It's not just the presentation of the thing. It's how you show them the overall thing that you've tried and asking, hey, does this follow closely? Does this meet the same A to Z steps that you had envisioned here? And if not, one has to reformulate. And so the less ability to negotiate about what needs to be reformulated or refactored adds to the problem. Beyond that, thank you and enjoy the rest of your day.